Okay, so it's 4 o'clock, and I'm going to go ahead and begin. Um, my name is Hugh Lobel. I'm the lead creator and developer of the music and sound design platform. Today, I'm going to be streaming as I convert this synthesizer that I have in front of me here into a module in MSDP. So I'm going to go through the entire process from even downloading the code to opening it to finding the templates, putting these things together piece by piece so that anyone who's interested can replicate the process in the future with their own methods. What I have in front of me today is the BFG Wave Shaper by Timo Hoogland. I will come back to this in a moment. What you see on the left is the developer console that opens up when Music SDP is opened in source code. So I'm actually going to close out of some of this. In the top right corner, you see my face with some effects added to it. This is all done in Max MSP, the language that Music SDP is built in. So that's why I decided to go with these fun effects today instead of just doing a normal video stream. So I'm actually going to close out of this for a moment. I'm going to close out of this, and I'm going to close out of this. And you'll see that we have in front of us just a handful of patches. These are the patches that we're going to convert into Music SDP modules, or Music SDP module. But I wanted to start by showing you how to get the source code and how to open it up and run it. So here we are on the download page for Music SDP from musicsdp.com. And to download the source code, we just click the download source code button. Now, instead of downloading the latest stable build, which is identical to the current release that's available in App State, we're going to go ahead and head to GitHub. And GitHub has the most recent version of the build, and I've made a lot of changes to this build, to the templates in this build. I've added a number of tweaks and refinements, and I have added a number of new abstractions that makes it much easier to build from the templates your own effects. So from the GitHub for our Music SDP source code, all you need to do is click the clone or download button and then hit download zip. That will download a zipped file to your downloads folder, which you can then extract. I'm going to skip that process now, but it's pretty straightforward. So once you have that extracted, let's go to the source code. You should see a folder that has this contents in it. So you'll see that we have our system files, we have a changelog, our license and readme. Here's the file that we want to run to open up the source code, but if you haven't run the source code before, you're going to want to install the fonts first. So you'll see there's a folder named fonts at the very top. Just double click that folder, select and install everything. These are Google fonts. And once those are installed, everything will display properly within the code. So install that, then double click the Music SDP patch to load the source code developer console. Now from here, if I wanted to, I could click this big button that says launch and run Music SDP, and that would open up the program sort of in its application state. So this would be equivalent to running the application download, and it works identically to that. That's not what we want to do today. We want to treat this more malleably. We want to be able to open up patches, to modify them, and to test things out as we go. So I'm going to not click the launch and run Music SDP button. Instead, I'm going to show you some of these features that we have here. One nice thing about keeping this developer console open is that we can quickly make a board, and this works just like an app state, right? But we don't have any of the additional content like the system board. We actually are accessing a default project folder, which is in our documents. If you go to documents, you'll see a Music SDP folder, and in there's a default project. So this will act as our project while we're developing. And since I've used this in the past, I already have some content in here. I have some audio files. I have some boards where I've tested things out there. I'm really creative with my names, right? And that's what we're going to access when we load boards while in the developer console. And this works just like a normal version of Music SDP would work. I can load the audio files that are in this default project and I can play them back. But you'll see that the signal comes out of the developer console instead of out of the system board. Right? So this is basically a stripped down version of Music SDP. We have loaded everything that we need to work when we load this file. And it is actually critical that we load the developer console before we start working. And I'll go into why that's required now. So in the source code, we have our system files. In this folder, the system files is all the files that go into the app state. And there are a number of files in here that are required in order to make the module building process go smoothly. So if you open up the source code folder and go right into system files and dig right in, you will see that certain things don't load and you'll have a lot of issues arise as you work. So I always recommend loading the developer console first and then going from there. So, one moment. Okay. Next, let's look at how we start building modules in Music SDP. So to start building modules, we're going to go into the source code folder. We're going to go into the system files folder and then modules. Now here we're going to see these are actually all the patches that load the various modules that are included in the MSDP application. So you can see here are filters. All of our filters are in one folder. All of our instruments are in another folder. If you really want to play around and have fun, there's some ancient legacy effects that basically don't completely function in the system anymore, but with a little bit of tweaking you can see some stuff that I built before this program ever really went live. Here are utilities, and near the bottom you'll see the templates folder. Now these files do not get loaded into our pedal board, right? So when we go to choose module, we don't see a templates section here. And that's intentional. These are specifically for development purposes. They're intended to make the development process go more smoothly. And it also includes a number of tutorials. So to really quickly crack open some of these, so you can see, here's a dial tutorial, and it walks you through how to generate and how to use the various dials that have been made for MSDP's interfaces. Let's see, down here we have the module tab tutorial, which explains how to set up tabs and how to think about tabs. And we'll be borrowing a little bit from all of these tutorials today, but we'll be wrapping everything that we do in the synthesizer template. Now the templates, unlike the tutorials, are actually fully functional modules. They're just not very exciting. This module, for example, is a fully functioning synthesizer. I can click notes on the keyboard and it makes sounds. I do have a hardware keyboard with me today, and you can see if I start to play notes, immediately that begins to make music in the synthesizer template, as that is connected to that and already fully functioning. So we have the ability to change parameters, we have the ability to control the volume, and this, if you loaded this template up into a pedal board, you would see that you could actually set the parameters and have the parameters change via other modules or via scores, just like you could with any of the full modules in the collection. So what gets really exciting is when we crack this open and look at what's on the inside. Now this template actually includes all of the code required to get everything working within Music SDP. And if you've worked in Macs before, you can see that it's not actually much code at all. What I've done is I have wrapped most of the processes into abstractions, and I've designed these abstractions to be basically completely built, and they don't actually need to be edited or modified by you in order for things to work. There are a handful of abstractions that we will add to this, and I'll be walking through all of that one bit at a time as we go through this building process. But just as a point of reference, if you want to follow along, the main template that we'll be using today is the synthesizer template. Okay, so next, let's peek again at the BFG Wavetable Synthesizer that Timo Högland built. So here we have 3 files. Only 2 of them are necessary. Actually, this third one was something that I was just testing out before the stream. I can even get rid of that, but I'll leave it for now. And if I load this first one, we'll see what I had open at the very beginning of the stream. So this synthesizer is pretty fascinating. If you look here, we have a little graphic display. Right? We have a keyboard up here. We have a variety of parameters over here. The way that the BFG Wave Shaper was designed is that we are going to be generating 3-dimensional shapes based on a variety of different presets. Various types of noise superimposed into 3 dimensions, and fractal shapes superimposed into 3 dimensions. What we're going to do from there is we have this line that scrubs from the top to the bottom of this shape and generates 2-dimensional buffers that we can use to make sound. So if I start to play a note, that's a little too quiet. There we go. Now if I start to make a note, we will actually hear that the timbre of the sound itself is changing as this pointer sort of scrubs back and forth over our 3-dimensional shape that we've built. There are a lot of other controls in here, right? So one thing that's nice is, along with that pointer, we can actually move to different directions upon this drawn shape. So you can see we can sort of scrub around in 2 dimensions like that to find additional buffer shapes for our synthesis. It's a lot of fun. You can hear that even if we just leave that static and let the pointer scrub back and forth, we get this beautiful sort of morphing timbre. Now, let me stop that for a moment. I had a really nice long release. You can see that we have up here our basic set of controls. We can choose what shape to draw, and we can actually choose what scale to draw that shape at, right? So you can see as I pull this dial in, it's like we're zooming in on the noise that's being drawn, and as I pull that out, we're zooming back out. This is nice because it allows us to sort of create more or less complex waveforms in our buffer as we go. And we can actually hear that change too if I play a note again. And now, because this waveform gets less complex, here, you can hear there's a lot less high-frequency noise with that simple waveform, and this sounds much more like what we'd expect from something more like a sinusoidal waveform. Whereas if we begin to scale out, we start to hear a lot more sidebands. Ooh, and then it gets really sort of thorny and crunchy when we've scaled all the way out. We do have a smoothing parameter here, and what this does is it determines how much smoothing there is between these buffers as they update. So if we turn the smoothing all the way up, we'll hear less variance as the buffer changes. But if we bring this buffer all the way down, it becomes a little bit harsher. We'll hear the variance more, and if we bring it all the way down, it's like we can almost hear the points as the buffer updates. So we're no longer interpolating between the buffers, but we're just hearing each one along the path, which is a neat effect at certain we want something smoother, we want to turn that interpolation up. I actually like to leave the interpolation around 10 or 11%. Now, below that, we have some more traditional synthesizer parameters. We have an amplitude envelope, attack, decay, sustain, and release. You can see the release is really, really high, but if I pull that down and then drop that note from before, it's instantly off, right? If, on the other hand, I bring the attack way, way up and play a note, you can hear that note sort of come in over 122 milliseconds. Let's bring that up significantly more. So let's have the attack happen over 1 second. You can hear that swell in, right? So that's a pretty standard ADSR. To the right of that, we have some frequency modulation tools. And Timo actually implemented an ADSR envelope for how the frequency modulation comes in and out of the note. Now, this is not an amplitude envelope. This is an envelope for the frequency modulation itself. We also have pretty standard an index value for the frequency modulation and a depth value for the frequency modulation. And this also adds quite a bit of variance to the texture. So if I play a note again, and turn that depth down, you can hear that very slow sort of shift from the frequency modulation. If I bring that index up and that depth up, it starts to get pretty wild, right? A high depth over frequency modulation always gives us a nice sort of intense effect. But a low depth and a low index just adds a bit more complexity to the timbre and makes it even crunchier. Okay, now, below that, we actually can control the rate and the size of the oscillation of the pointer. So you can see right now we have shape mod. As we crank this dial up, the pointer starts to sweep back and forth more quickly. And so that can actually go really fast if we want to. And let's listen to that for a moment. That's a pretty neat effect as we bring that up and down, right? And then the depth, on the other hand, determines how much of a sweep we have with the pointer. So I'll pull that depth all the way up, and we can see that huge sweep happening now. And if I pull that frequency up now, it's quite a process, right? I really like a slow sweep, so I tend to keep this pretty low. Finally, there's a low-pass filter, just sort of wrapping over everything, just to give us one more tweak to the timbre of whatever it is that we're making. Pretty standard low-pass. Finally, there are a few parameters at the very bottom that are exclusive to the fractal waveform types. So I'll show you one of those. Now we've drawn this fractal shape, and I'll zoom in just a little bit. So for these fractal shapes, we can increase or decrease the detail on the fractal, and I love that process. We can increase or decrease the roughness of the fractal, so there's that roughness all the way up. It's actually very different from what we saw just a millisecond ago. And as we pull that roughness down, we can actually get somewhere quite smooth. So between roughness and detail, we can add a lot more variety to the waveforms for our fractal shapes. Linearity, again, has a very similar effect. As we pull that down, we get a sort of a flatter texture, and as I pull that up, we begin to get something that's more rigid, right? So if we wanted something that was very, very, very complex, we could turn all of these things up, and now we have a ridiculously noisy waveform. Finally, there's one neat little toggle that we can hit for these fractals. If I hit the rotate button, you can see that it simply rotates the axis of the fractal. Note that these parameters do not apply if we're working with noise, right? So nothing will update if we change these parameters when we're working with noise. So if I'm going to convert this into an MSDP module, there are some things I need to figure out. I need to figure out how I'm going to organize all of this because we have a lot of parameters here, and as we know at this point, MSDP modules do not have a whole lot of blank space in them, right? So we'll need to decide organization. And once we know how we're going to organize it, we're going to need to transport all of the content of this synthesizer into the synthesizer template, and then we need to start hooking up the MSDP parameters and the MSDP interface objects, replacing what we have so far with these live dials, so that we have our user interface that's unique to our aesthetic. And then we'll set up the parameter input and output routing so that this can communicate with other modules and with controllers in our system. After that, we'll implement the tabbing, because again, we're not going to have enough room to fit everything onto one screen, so we'll need to have a set of tabs that allows us to toggle between different sets of options. And then once we have all that set up, we'll begin to test it. So first, let me talk about how I plan on organizing this particular synthesizer. I tend to have the first tab be the most important processes. So that will include the waveform shape and the pointer. It will also include the waveform selector, the scale knob, and the smooth knob, and that will be our sort of basic tab. The second tab will be our advanced options. I'm actually going to keep the amplitude envelopes on a third tab. The second tab will have our FM index and depth, our pointer LFO, low pass filter, and fractal exclusive parameters. So then it will be the third tab that contains the ADSR for the amplitude and for the frequency modulation. And that should be enough. 3 tabs ought to be enough. If we need to extend it to 4, it shouldn't be too hard. We'll have to feel that out as we go through the module building process. So let's see. Really quickly, let's crack open this tool. It's not super pretty to look at, but it's also not too bad. I've definitely seen synthesizers that look a lot worse than this. You can see that I went ahead and implemented one of the MSDP dials. That was just a test I wanted to do before I started. You can see there's a lot of sort of clutter here that all revolves around drawing this waveform and then allowing us to navigate around it. And if I go full screen, what we can see on the right, this is the actual synthesis core. Now, when Timo built this was monophonic. I went ahead and converted it to a polyphonic synth, meaning we can play multiple notes at once. And I did a couple of other things to prep this for MSDP, particularly in the polytilde object. Right? So if you've worked in Max before, you know that if we want to have multiple notes sounding at one time, we need to wrap the synthesizer in a polytilde object. So that has been done already. And we're routing all of our parameters, which are currently Ableton Live mod dials. We're routing all of those parameters into the polytilde. We're basically going to do a massive copy-paste of most of what we see here. We're not going to need everything. We won't need this keyboard. That's already going to exist. But that's what we're going to start our actual work with. So I'm going to close that pedal board. I'm going to close that buffer display. Let's see, I guess I should save that work here. Now I need to go back to the synthesizer template from before. Alright, so I'll walk through that process one more time of how to get there. This is the source code for Music SDP open in front of me. I'm going to navigate into the System Files folder, and then I'm going to navigate into Modules. And from there I'm going to go to Templates, and the very bottom one, Synthesizer Template. Now, before we get started, one quick discussion around the templates and the necessary included files that go with them. I have very recently, over the last month or so, created a series of updates to these templates to streamline the process and to make it easier to work with. One part of doing that is I've built a series of new abstractions. These are max patches to make this work. What that means is if you want to build your own module, you will need to wait until the next release before you can share that module with the application users. It'll work fine for anybody using the source code, but it won't work fine for anyone who's using the application form of Music SDP because those new abstractions don't exist in the most recent release. Now there is one way around that. If you really want to release this before the next update, I'm hoping the next update will go live by the end of June, but if you can't wait that long, later on in this stream I will show you how to get those necessary abstractions into the application state so that other people can use it as well. Again, if you have any questions as I go through this process, I'd be happy to answer questions as I go, but otherwise I'm just going to continue to dig into this whole process. So now let's look at these templates and how I've designed these templates to work. All right. First, my color schemes. I'm not really sure how I came up with them. They're not that intentional. They do specify something, and that's what I'm going to make sure to talk about. So if you look around this patch, you'll see a number of abstractions, a number of objects that start with MSDP dot something. Right? So these abstractions are the tools that communicate with each other and are going to simplify the process for us as we build our module today. The vast majority of these abstractions we will never have to touch. They're pre-built for you, they're fully functional, and they don't need to be modified. Let me talk very quickly about what each one of these does so you know what I'm doing. In the very top right hand corner we have just this teeny tiny box, and our first abstraction, msdp.module.routing. This abstraction is going to take care of all of the parameter routing for us for our module. It's going to take information in from other modules, from controllers, from scores, and send it to our parameters. So back in the example, right, we have a parameter that is a volume knob, we have a parameter that is a float box, and we have a parameter that is a case slider or a keyboard. The module routing is what will send parameter data to any of our user interface objects from the other parts of the system. We won't need to touch that. And actually, anything that is in one of these sort of burnt yellow panels, this is all code that you won't need to touch, you won't need to edit. This is all done for you. So going from top to bottom, from this side, here we have our output signal routing controls. This should look familiar. This is how we set up and how we send out the set of outputs for our object, for our module. Again, this does not need to be modified. There are a few situations where you may want to modify it, say if you wanted to add more outputs, or if you decided you only need one output, but this is where that would be done from. Below that, this is where all of our parameters get saved and sent out of the module. This will gather data from our float point, from our dial, from whatever it is that we need our users to be able to interact with. This will gather all of that and send it on to the board save state. It will send it on to other modules if we need to. And this is also where we can save presets. So all of this code just runs itself. We don't have to touch it. If we go to the left now, Here's a little bit of information that we do need to provide for our parameters as we wrap up the module, and we'll come back to that at that point. So anything that's in a blue panel does either need to be modified or need to be addressed in some way. It's possible that the material in the blue panel doesn't even need to exist in your module in order for it to work. This poly tilde object we're going to scrap because we don't need that. This example parameter is something else that we may decide to scrap pretty quickly. But if we go down from here, this is all of the signal output routing. Now this is different from the signal output parameter, right? This is where we're actually going to set the parameters of we need the signal to go to this module, or to go to that module, or to go to the master out. This down here in the bottom left corner of the template, this is the actual signal routing. So any signal that your process generates or processes needs to be plugged into the MSDP module output stereo object in order to get that signal to go out into the world to be heard. Coming up from there, this is simply some example code. If you want to look at an example of how to put together a poly object for a synthesizer or for an instrument, I'd recommend looking over that sample code. But this is stuff that I'm actually going to delete pretty quickly once we get started. Now moving up from here, this is the code. Everything in this little burnt yellow box assists with the integration of keyboard for instruments. Right? So this will only be necessary for synthesizers or anything where you are building an instrument that's going to be played via a keyboard. Right? So here we can see this determines whether hardware controllers can play the built-in keyboard. If we get notes stuck on, we can flush it, and then this is, let me turn that volume down. This just allows us to shift the display of the keyboard that we've selected. So you'll notice that the keyboard is actually in a blue panel instead of a yellow panel. This is because I suspect that from one module to another you may need your keyboard to be shorter or longer, or you might want it to cover a different set of, a different range of MIDI notes. You may want to change the color of it. So this is something that you may want to address, but you actually don't necessarily need to. Alright, this is that same synthesizer then laid out into the module. So one last thing I want to look at with the template is what this looks like in patching, in presentation mode, right? So right now we're in patching mode. This is where we'll do all of our work, but this is not what a user would want to see when they're playing around in Music SDP, right? That user is going to want to see what we see in presentation mode. So we have all of these default starting parameters already laid out for us, which gives us a good starting point. And we see these dotted lines as they stop and stop here. These dotted lines are based on the actual scale, the actual scope of an empty module. And so as long as our user interface objects stay within this box, everything that we build can be displayed in here. And obviously if we compare everything that we see here to everything that we see here, we can tell we're going to run out of room quickly. So let's start building, like really actually do this. Instead of building directly into the synthesizer template, I'm going to make a copy of this file. That way I can always come back to the template should I need to later. Now I can also just re-download the template from GitHub, but that's more trouble than it's worth. So I just did a quick copy-paste to make a copy of the synthesizer template, and I'm going to rename this Wavetable Synth. Now, I'm not totally certain that that is the ultimate name I'm going to give it, but that will do for now. We don't need to have underscores or dots between the words in our files. They can have spaces, and that will be recognized, and that's not a problem. So I went ahead and put a space in there for Wavetable Synth, and I'm going to reopen now that tool. Okay, so here's where we do the big copy-paste, and we start to sort of expunge the files that or the objects that we don't need from both the template and from the original BFG Wavetable Synthesizer. So back in presentation mode, over here, I'm going to just quickly delete everything that I don't need, which was that original synthesizer sound. Next, I'm going to start to make some room. Right? So I don't really want everything to be that cluttered together, especially since we've seen that the original code does take up quite a bit of space. So I'm just going to move these objects out of the way. Yeah, that'll be good. I like to keep the output stuff at the bottom right, and the input stuff at the top right. And the signal, output and input signal, on the top and bottom left. That's just how I generally organize my workflow. It's not required that you follow that, but I do find that that helps me keep clear in my head where I am. Okay, so the next thing that I'm going to want to do is I'm going to want to go back to the original code by Timo Höglund. Here's the BFG core. Now this is what we call a required file. This is the content that's in the polytilde object that we saw before. So I need this to be in a specific folder. For me, since I'm going to build this directly into the core of the program, I'm going to put this into a folder in the system files folder called includes. And I'm just going to keep it at its original name. So I'm going to copy and paste that. So copy and paste that into the core. Now, if you're building your own modules and you want to distribute them, you can't really put them into the core package like I just did, because when we build the application, your includes won't be with that full application build. So whatever you've created won't function when you share it with others. The workaround for that is that when you distribute your module, you will need to provide instructions or an installer to place into the MSDP folder in the document tree. So now I'm in Documents, and you can see Music SDP. You see third-party includes. This is where we'd want to place our poly file or whatever included file we need if we're building for distribution. So that's now in the third-party includes, but that's going to create for me a conflict because I'll have too many instances of that file. So I'm going to get rid of that, but this is where you would want it to be as you were building your version of whatever it is you wanted to build. So I'm going to delete that now, but I still have a copy of it in my source code. So there's source code, system files, includes, there's a lot in here, BFG core. All right, so here's the big copy paste. What we don't need from here is this. So I'm going to go ahead and delete that so I don't get confused. We are going to copy and paste that text so that anyone who comes back to this in the future who wants to understand how it's built does know that this began as a project by Timo. Let's see. I guess we don't really need to delete anything else just yet. So I'm just going to do a select all, which is of course Command A on a Mac or Control A on a PC. I'm going to copy that, and then, oh boy, this is kind of scary because sometimes this can crash Macs if you do a big paste. So if everything disappears, I apologize. Okay, there we go. The paste happened successfully and nothing crashed, thank goodness. Let's see. Now I do need to check on one thing because I believe there may be a problem now with the stream. So I'm going to sort of pause my discussion for one moment while I check on the strength of the stream. Let's see. I'm just going to load up YouTube really quickly. Let's see how the live stream is doing. Okay, good. We are still streaming. Excellent. All right. Now, back to what I was doing. Let me make sure that, yeah, we're getting audio from the microphone. Okay. So, now that I've double checked that, let's look again. And boy, this just got a lot messier, right? We're going to need to make room for all of this before we can continue. I'm going to get that stuff out of the way. And this is, this can actually be deleted. That has to do with the keyboard. And we're going to use the keyboard that comes with this particular template anyways. Let me get that out of the way. I'm just going to clear out. All right, good. I'm going to move this further over. Should have seen that one coming. All right. That looks really cleared out of the way now. All right. And this is going to be hard to navigate. I have to detangle this stuff. But we can do this. Thankfully, there's not a whole lot of objects here that have to move. So I'm going to try to select all of this stuff. Bah. Well, you know what? Let's start by moving this. Ha! I almost got all of it. Great. I'll clear that out. Whew, okay. Good, that feels quite a bit better. So, I'm going to put Timo's notes over here. Alright. Let's see. So those stay. And now, we basically have everything back in. You can see that looks like the polytilde object loaded. Great. Okay, so we've got everything in. We just need to hook it up now. I'm actually going to swap the location of all of the jitter graphical drawing and the actual synthesis. Oh, look, that slides right in there. Since all of the audio in and out is on the left anyways. Yep, lost a dial. We're going to get rid of those shortly. Doesn't matter. I'll plop this over here. Okay. Alright. Now, the way that this keyboard, MSDP parameter keyboard is built, is it sends note data from a synthesizer from somewhere else in Music SDP. It sends note data into the keyboard. The keyboard goes into it, and it does a little bit of processing to prep for the poly object, and then out of the right outlet, we plug that into the poly object. So this keyboard is now already controlling the polytilde object BFG core that we copied in before. And that's going to output a signal. And that signal is what we want to hear as we go to different parts of the system. Now this is a mono out. It's only sending one channel out. But everything sort of gets wrapped into stereo in Music STP anyways. So I'm going to take that single channel and I'm going to plug it into the left and right inlet of the MSDP module output stereo. Right, and that was already in here. That's just part of the preset. Right? So that's all the synthesis core right there. Everything else that we see has to do with drawing that waveform and copying it into buffers so that we can play those as a synthesized sound. I'm going to bring that back up, but I am going to keep it separate. There's a lot of placeholder copy that's going to appear in the presentation view, but we'll probably get rid of that too. The auto patter, actually, that's something we don't need, so I'll go ahead and cut that out. And at this point, we actually should be able to get sound and to make this work in Music SDP, but first we have to reload the patch so that we can get our waveform back, because you can see that that shape is no longer drawing. So very quickly, just close that. Then back to System Files, Modules, Templates. There's the Wavetable synth that we built. Doesn't need to stay in templates, but it might as well for the moment. And I'll reopen that. And there's our waveform. Now you can see this is a little too crowded, right? As we're back in presentation view. But as a test of functionality, we don't need that demonstration title either. As a test of functionality, maybe... no sound yet. Darn. We'll have to look and figure out what else is missing. But I actually like this size that I chose. I think I had a good idea of what would fit well and what wouldn't. I'm going to move some stuff out of the way. And let's see if we can figure out why that didn't send any signal out. So, first, I'll play some notes and let's see what... Oh, there it goes. All right. So that is working. Yeah, look at all this sort of stuff. We should probably get out of the way. Right. Nice to have a title. Oh, and if there's room, we should definitely keep that in there because that's a nice touch. Here's sort of our basic controls, though, right? Here's our presets, and remember, the preset routing is actually going to be taken care of for you. You don't need to do anything to get that functioning, and we'll look at that later too. We may decide later on to reduce the size of this keyboard, but if we can avoid it, then we'll leave it that size, because that is a really satisfying size. So, let me turn those notes off. And everything works. Right, we can scale that fractal. Yes, great sound. Okay. So what's cool is at this point we can already begin to test the system. These parameters aren't going to update yet, but since we did already send the output of the polytilde into the MSDP module output abstraction, we should be able to send the signal from here into other parts of Music SDP. So back in the developer console, I clicked Create New Board to make a fresh board, and we will just, let's leave this over here, put that over here, and I will switch over. I usually start by testing, throwing a signal into a chorus pedal, just because it's a pretty clear sound. And let's set the output of the chorus pedal, or the output of the Wavetable Synthesizer to A1, and the input of the chorus pedal to A1. So now we won't hear the signal coming out of here. If we're successful, we'll hear the signal coming out of the chorus. There it is. Not the prettiest sound I've ever made, but it's there, and we can play with the chorus pedal to hear that it is actually doing something. So right away, we already see that this is working within the Music SDP framework. Okay, I'm going to close this, which will kill the sound, right? Because now we're only sending signal to the A1 output, and we've just kind of deleted that, so it no longer exists. So let me flush that keyboard. Another thing that we can test now already is my hardware, right? So I should already be able to play it, and boom, right away, as soon as I press a key, we do see sound, or we see a note being pressed on the K slider, and if I switch that back to the master out, we hear it. So it is that instantaneous. That's one of the nice things about using these templates. Okay, so we have effectively ported the entire thing in at this point. That's all it took. It was a big copy-paste. That was step one. Well, so I guess step one was making room for the pasted content. Then step two was copying it in, pasting it in. Step three was making sure that I had the signal going out of the polytilde to the MSDP module output, and making sure that I was routing the data from the keyboard properly into the polytilde object. Again, you can reference the synthesizer template if you want to go over that again, or you can, rewind this video once it's fully loaded. So, okay, at this point, the next step is to replace these live dials with our Music STP dials, and to get everything routing as Music STP parameters. So at this point, I'm actually going to grab another template. So back in the source code, again, that's source code, system files, modules, templates. I'm going to go to the dial tutorial. I'll crack that open, and this sort of explains how to set up the Music STP dials. I'm not going to go into great depth on this right now. If you are really interested in how this works, I recommend downloading the code and just looking at the tutorial file. But what's nice about this is we have a bunch of sort of pre-built dials, and I can grab what I want from this. Now, because of the sheer number of parameters in this, and because of the fact that I like keeping it dial-based, we're just going to use the extra small dials for this one. And you'll notice that the dials aren't by themselves. They actually come with this MSDP.param abstraction along with it. So that's what I'm going to talk about next as I do a little more copy pasting. So we want this dial, a little tiny one. I'm going to grab that. And so I did a copy on that. Select both of them, right click, copy, and then where appropriate, paste. Now I did this once before. You can see I've already brought one in there. And now we have a dial with its appropriate parameter abstraction added to it. I should mute my phone. Okay. So now this dial moves up and down, but only moves between values of 0 and 1. So we're going to need to set each of these dials parameters to match the live dials that have already been placed in here. If you want to use the live dials as you build your modules, or if you want to use the max dials, that will work just fine, actually. You don't need to use the MSDP dials. I'm going to use it for stylistic consistency, but you should use whatever is most interesting to you. So if you want to use the live dials, but you want to integrate the parameter routing functions, all you need to grab then is the MSDP param.line object. So let me talk about that object next. I have built a series of abstractions that you can connect any user interface object to, and it will take care of all of the parameter data input and output routing for you. So when I talk about parameter data, I'm talking about, say, what value is this dial at. Right? So we know that we can save boards in MSDP, and when we reload them, the dial is right where we left it, or a number box, or the keyboard is right where we left it. Another way that we see parameter routing and saving being important is with presets, right? We can save our dials and our parameters at different locations and recall them as we want. We can also use controllers, we can use scores, and we can use the virtual controllers, and we can use other modules to update the values of parameters. All of that is done by simply plugging whatever user interface object you need to route into one of these msdp.param objects. And there's a series of them. They serve different functions. You can see over here there's an msdp.param.keyboard, right? And that is a special abstraction just for keyboards. You really don't need to do any settings for this. If you're going to make a synthesizer, you can just use the one that comes with it. But for any other interface object that we want to create, we'll need to build a parameter object with it. You can see one is set up already for the volume dial, right? There's the volume dial, there's the MSDP.param object. And as you can see, what we do with this is we plug the left output of the param object into our user interface object, and then we plug our user interface object's left output back into the left input of this param object. Now there's always at least one other input. The second input must stay open in order to make things work. But as long as you remember that, again, these things work automatically and they function just fine. Okay, so we've got one dial. Oof, here comes the replacement process, basically. We're going to need to make a lot of copies of these dials. And here we have to think again about design, because we need to start thinking about what our parameter order is, right? So parameters 1, 2, and 3 will be our keyboard for 1, our output destinations for 2, and our volume for 3. Now, in my opinion, the next most important question is what type of waveform do we want? So I'm going to call that parameter 4. I'm actually going to get rid of the view buffer because even though it's a nice feature, it's probably just going to take up space. I'm not going to delete it yet. I might decide to bring it back in later, but for now I'm going to just select that and choose remove from presentation. Now I haven't deleted that code, it's just hidden. Right? So we've got parameter 4 is going to be select the waveform type, and let's do parameter 5 as scale, and parameter 6 will be smoothing. And maybe, yeah, it's a good starting point. So back in the editing view, I need to find that scale, or, well, there's delay. Now why isn't that showing on presentation? That is showing on presentation, but I think it might be hidden. Ah, there it is, right there. Nope, that's scale. Here it is. It was hidden. It was hidden behind my camera. Okay, so we've got scale and delay. Let's make that a little bit wider so we can see all the text. Okay, now we know that those numbers are wrong. We want those to be different parameters, but we'll come back to that in a moment. We don't want everything to be parameter 4, right? So back in editing, I still need to find that drop-down menu for the waveform shape. Where is that one hiding? Ah, here it is. Perfect. Okay, so I'm going to get rid of some of Timo's comments, and I'm going to make a new MSDP param object. So MSDP.param. So when we create a param object, it has 2 arguments. The first argument is the parameter name, and the second argument is the default value. Okay, so this parameter name is parameter 4. Right? It's not parameter 5 or 6 or 7. It's going to be 4. So this is a Music SDP protocol that I use to make sure that parameter's routing works. The parameter name is P for parameter, followed by the number of the parameter. So to specify this as parameter 4, I'm going to type in P4 as the first argument. Now the second argument is that starting value. Right? So this will be, in this scenario, it'll be a number, right? What number do we want from this uMenu list? And I'll set it to 0 for now. I can come back and modify that later. And what that means is it's going to select the 0th index of the menu, which is fractal mono. Whenever the module loads in a blank module, in a blank board, into a blank module on a board. There we go. So that's the first step, is I built the parameter object, I plugged it into the user interface object, and then the final step is to take the output of the interface and plug it back in. Now there's actually one final step that I need to do, and this will have to do with all these abstractions, all these MSDP parameter objects. We need to give it a scripting name, and the scripting name must be the same as our parameter name. So P4 is the scripting name, P4 is the parameter name, P4 is the scripting name, P4. Okay, and now it's done. or at least that one is. This process will go faster as we move forward because for the most part we'll be copy pasting. Alright, let me get that out of the way. We will have to come back to the inspector, so maybe I'll move this screen over here. Okay. That kind of threw me off. So now the parameter routing for that is complete. That's done. The next thing that we wanted to do was to replace the scale object, the scale knob, with an MSDP dial. And you can see they've already done it. And if you notice when Timo built this, he gave it a sort of exponential curve. So it starts at a value of 0.1 as the lowest point in the scale. And it climbs up. It doesn't really reach 1 until we're about a third of the way up. And then from there it starts to climb the rest of the way between 1 and 10. So we can replicate that with MSDP dials. It's not 100% the same, but it's pretty darn close. Alright, there's the 106, and you can see it's not 100% identical, but it really gets us there. So I will look at how to create the dial in a moment, or how to set these parameters and these names. Actually, I guess I should do that now because this is not the 4th parameter, it's the 5th parameter, right? So to set the dial, we need to go back to the inspector. I'm going to right-click on the dial, choose inspector, and you can see that it has a series of arguments. This is actually a B patcher for anyone who's wondering. And we see a series of arguments down here. And the first argument is the name that gets displayed on top of it. The second argument is the low value. The third argument is the high value. The fourth argument is f for floating point integer, or I for integer. And then the the fifth argument is exponential curve. Right, so I set that exponential curve to 3. If you don't want an exponential curve, if you want to be linear, you can actually just not fill anything in there. But we do want this one to be exponential. So let's change that to 5 scale. And as soon as I click off of that, you can see that updated. So here's another problem. This says P7. So let's set that to P5, and then let's update the scripting name here, P5. There we go. All right, back in the display. Let's remove that and replace it. So there's our first replacement, right? So then we need to set this one to be smooth. Now, smoothing, I think this one might be linear. So it goes between, nope, that is definitely exponential. So let me see what value he set for that one. Exponent 3. Okay, and it goes between a value of 1 and 100. Okay, and it's floating point, right? So over here, back in the arguments for our B patcher dial, I will call this 6 smooth. And notice that I'm putting the name in quotes. That's because we wanted to implement a space. So once we implement spaces, we have to specify that this is a string. If we didn't need a space in there, then the quotes wouldn't be required. But now we're going between values of, 1 and 100? Is that right? Let's check. Yeah. Okay. So our low value, we'll replace the 0 with 1. And the high value with 100. Notice that I'm leaving decimal points to specify that it is floating point values. Then the fourth argument is float, and the final argument is exponent. Ooh, and that just made something unhappy. Arguments will be updated when patcher is reloaded. Interesting. Because it definitely looks like it just reloaded. Huh. You know what? That is not something I've seen before. Fascinating. You learn new things. Let's try that one more time. Well, tell you what, let's just quickly close and reload the batch, right? Wavetable. And there it is. Now it's going between 1 and 100. And is that... So this is a little bit different, right? I'm not sure that my exponential numbers are quite accurate. I'm doing a little bit of math. That may not be totally right in building these. Oh, and there it is again. Let's put it at 3.5. And I'm going to switch back to, I'll clear that. Let's switch back to editing mode, find that dial again. Now, a default of 0.5 doesn't really make sense for this anymore, right? Since that is now out of the range that we set for the dial. So let's set that to let's see, smoothing. I like 10. Let's set the value to 10 as the default, and this is parameter 6. Okay. And then we need to change the scripting name to parameter 6. And we can replace the scale plug, or the smoothing. Let's just get rid of that. We're done with that one. Where is the smoothing dial? Must find smoothing. There it is. Alright, let's bring this stuff down to here. We'll plug it right in. Oh, he initializes it at 5. Oh, let's follow. No, you know what? I like 10. That's my personal preference. That's where I'm going to leave my version of this. Alright, check that. That's pretty nice. Okay, cool. Now you can see we have a lot left to do. So at this point, I'm just sort of well, no, let's think about this. Now, I may decide further down the road that I want the x and y values, which correspond to our coordinates on the wavetable, that I may want to implement that as part of the interface, but right now I don't think I'm going to. I think I'm going to keep it straightforward. So I'm going to actually remove that from presentation as well. Okay, so we've got 1, 2, 3, 4, 5, 6. What else are we going to put on the first screen? Probably this slider for location. So let's bring that back on, just so we can start to see how this is going to lay out. Let's see, I'll move this up here for now. Here's the position slider. I'm not crazy about those edges, but that's something we'll deal with later. Here's the waveform, and we want these objects as well. Ooh, and you can see that it's already getting crowded. Even at this point, it's getting crowded. So I'm going to do something that I often do. I'm going to lay the outputs along the bottom. Oh, look at that. I didn't even do that intentionally. It just lines up nicely. Okay. Lay that there. I'll place the comment in between. This is a pretty standard layout that I use. Frees up a little bit more real estate. Position that a bit. Let's put a volume over here. Okay, we can see now that's going to be too big, so I'll just scrunch it in. It looks like the comment is okay, so I'll leave that. And then we have room for scaling and smoothing. Woof. Okay. Now this should probably overlay like that. But we'll need to change the color of the text. Alright, that's nice. And, oh, it's already laid out. Perfect. So that's less than ideal. Alright, but it works. So let's see. We've got 1, 2, 3, 4, 5, 6. Let's do 7 for the slider location, for the pointer location. So we'll say 7 pointer location. Pointer location, and I'll tweak the copy later. And then 8 and 9 will be X and Y. Eight is X, 9 is Y. I think if I hide it sort of in that corner there, it should work well enough. You know, I'm not crazy about the fact that this background on the waveform is lighter than the other objects that we use, but I guess I will just have to address that later. Okay, so let's set up 7, 8, and 9. This will start to go faster now. We need to find this slider. There it is. Let's get these objects out of the way, because that's just creating clutter. And this can get out of the way. Okay, new MSDP Template. Now this is a value that can move, so we're going to make this a line value, meaning that the values can glide back and forth. Oh, look at that. That's no longer hanging out on the top. Huh. So then this is going to be, you said parameter 7, right? P7. And I believe this thing has values between 0 and 127, so let's set this to a default of 64 right in the middle. Plug that in there, plug that in there, and set the scripting name to P7. Cool, that's done. Now we need the X and the Y coordinates, which this is funny because they're being set sort of behind the scenes. And I'll actually have to tweak some things so that when these update, that it updates this. But I'll take care of that later on as I'm cleaning things up. I might not do that on this stream. So these are values between 0 and 12.5. Those are the values that I chose for this. So here's 0, 0. Here's 12.5, 12.5. Let's start more or less in the middle. So let's do P8. And this is also something that we can scoop back and forth. So we want this to be a line as well. We'll set that to a default value of 6. Let's do 6.5. 6.25, right? That'd be right between 12.5. And then we'll just do a duplicate of that and call it P9. And that will set these parameters right in the middle. Now it's not going to set this right away, and that's problematic. But again, that's something that I will tweak depending on the time that we have, either here or after the fact. Finally, set those scripting names. This is P8, and this one's P9. Okay, and that is done. I think that takes care of our first screen, right? So I always want to think and reflect, better to do it right the first time, right? So I have parameters 1, 2, 3, 4, 5, 6, 7, 8, and 9. And you know what? We should implement some sort of display of this. Maybe I'll build that later. But I do ultimately want to have these two numbers, the X and the Y coordinates, displaying somewhere in this image. But now that we know what's going to be on the first screen, let's get it out of the way. So I'm going to click and drag all this stuff and just move it down here for now. So yeah, notice how much I'm leaving up here. I think that all of this really is probably necessary for the synthesizer to work. Now, whether or not you decide to leave the keyboard on multiple tabs in your own design, yeah, but that's just how I like to work. So now on to the content of the second tab, which will basically be all of this and this. So I'll duplicate that. This is just a placeholder for me. Now we don't really need that because that's done. Oh shoot, I just realized we're going to need room for the tabs up here, and this is not leaving room. Okay. Think, man, think. Well, we may need to end up shrinking this after all. I was hoping that we wouldn't have to. But it might be a necessary evil in this situation. So let's see, we've got 144 by 110. Let's bring this down to 120 by 100 and see how that does. Oh, I forgot to do it on the actual waveform itself, or the window. So let's do that here too, 120 by 100. These are just dimensions that looked good to me. Oh gosh, I hate to go any smaller than that, but just for now, let's do 120 by 95. I'll probably end up tweaking this a little bit more after I finish here. But this is going to allow us to take everything that we have and just bring it down. So we're going to have some pretty narrow tabs, but better narrow tabs than, I don't know what the other option would be. It just wouldn't look good. Why don't we go ahead and bring the tabs in so that we know what that's going to look and we have that implemented moving forward. Okay, so I think we can close this now. To bring the tabs in, we're actually going to go back to templates, and I've got a pre-built tab set up in the module tab tutorial. So I'll crack that open. And the module tab code is pretty small, actually, really teeny tiny. It's just all of this stuff right here. It comes with the default parameter built in. So we're just going to copy and paste that whole sequence. Copy. Don't need this open anymore. And then we'll paste it over here. All right. And now we can start to see how that's going to lay out. Now this, I accidentally did this in presentation. We don't need this stuff in presentation, so I'm going to remove that. There are our music STP tabs, and you can see that's going to look pretty gnarly if it's small, but it's still legible. And now we know how placement's going to look. I'll probably dial that in a little bit more later. Maybe stretch that. Oh, too far. Yeah, we can tweak it later. And I will change the values on those tabs. It's just the names, right? We're back in the inspector. We do a lot of work in the inspector at this point. This doesn't need a, well, it does need a scripting name. We'll just call it tabs for now, if I can spell that right. All right, let's see, tab items. I'll call this basic, advanced, and envelopes. Might come back to it later, but that looks pretty good. Okay, so we got our basic, advanced, and envelopes tab. Our tab is probably going to be a pretty high parameter. We'll put a where's our tabs? Here we go. Here's our tabs. There's that whole sequence. Oh, and I grabbed something additional by accident. Don't want that. Yep, always got to be careful when copy pasting. I'll just move it down here for now. It's not actually going to need to connect directly to anything else, so it's kind of perfect where it is. We can just let it be. Okay. Next, we got a lot more dials to build because the second tab, once we get to it, is going to be just the set of 4 dials. That's kind of nice, or 8 dials. Even though there's a lot of copy pasting to do, it will be fairly easy to figure out how that fits on the screen. I should give this a little bit more room down here. Okay, so back to my notion of getting all of our interface objects out of the way that we're not going to see on this tab. Now we know what space we have to work in, right? So basically everything from here down is going to be our space for the individual tabs. Everything above it will stay static regardless of what tab we're on. We've done different tab designs, and you should look at, if you want to see some interesting tab designs, I'm a pretty big fan of the MIDI arpeggiator, I think is a nice one. As well as the A+2 synthesizer, which works pretty similarly to what we're building here. Okay, now for the copy pasting, and this is going to be kind of not so exciting. I apologize for that, but we got to start somewhere. Let's make this tab parameter 100 so it's not overlapping with anything. We'll come back and change it later. P100. Good to have a placeholder. Okay. So let's decide the order of events for this screen. Oh, which is these actually. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think the low pass filter, I think the fractal parameters should be last on this screen, since those are only going to apply to the fractal waveforms. The pointer LFO, FM tools, and low pass filter could all be the first set of tools. So actually I think I'm going to keep these dividers. I kind of like that. Maybe even keep it like that. So we need to understand the design before we understand the order of the parameters, right? Otherwise it may not totally make sense in our head before we build this. So let's see, pointer LFO, FM tools, and low pass filter. I think that can all be sort of on one top column. Maybe just as a sequence of 5 objects, 5 dials like that. Yeah, I think that's going to be best. I'm going to lay those out, even though this is going to be replaced by MSDP dials. Still good to have a starting point. And that way you can see, like, oh, I need to center this a little bit more. I need another barrier there between these so that we are separating function, right? And then on the bottom, we'll place the fractal exclusive parameters. I'll probably need to figure out something for the interface. As you can see that's not really lining up within the boundaries of our module. Almost, that's getting kind of close. I'll sneak that in a little bit more. And now we have just enough room, I think, to bring these up. Yeah, you can see that fitting everything into the module boundaries can be quite a challenge sometimes. So luckily it looks like we do have room to move everything up. Maybe not those barriers. Oof, danger. Maybe keep those where they are. And move the rest up. I gotta realign that. Okay. Now these can come down again. Yeah, and we'll fine-tune this once I've replaced these with the MSDP dials. But basically this is going to be our second tab now. Got the pointer LFO, FM tools, low pass filter, and the fractal exclusive parameters. Yeah, okay, now time to start wrapping these in dials, in MSDP dials. So the first one is pointer LFO shape mod, which is really LFO frequency. We've got frequency and depth, so I think I'm going to call them frequency and depth instead. But Timo has called them shape mod and mod depth, which we need to know in order to find out where they are. Easy. Alright, so we'll just copy paste my favorite command. Get some of these out of the way. Move this out of the way. Okay. Now, the shape mod's moving between 0 Hz and 3 Hz, and this does look... Oh, it's also exponential. Nice, but I think I might keep it... No, I think that's a good call. So, let's see, this is going to be parameter, let's see, we did 1 through 9. Ooh, there's the new one. 1 through 9 on the first tab, so it's going to be 10, 11, 12, 13, 14, 15, 16, 17, and 18. Alright, so this is parameter 10. And this is frequency, so we'll do 10 freak is a shorthand for that I'll use. And it's going to be a value between, I guess 0, because we don't necessarily want this one on, and 3. As the high value, we'll keep this floating point and we'll keep it exponential. There we go. Nice curve. I like that one. So now we just start replacing, right? We don't need the inspector to be quite that big right now. So we'll see that the original dial is plugged into this sig tilde. I'll replace that. Gone. This is parameter 10. We just set that in the MSDP parameter routing object and set the scripting name to P10. That's done. Next we have depth, and depth goes from 0 to 1, and that does look linear. Alright, easy pie. Duplicate. Rename. So this will be 11 depth, depth from 0 to 1. And since this is linear, we're just going to leave the last argument off. So our arguments are name, low value, high value, and floating point. And that's working. Works beautifully. We'll plug that in, replacing the initial one. And we need to set this to parameter 11. And the scripting name should be parameter 11 there too. All right. Yeah, you can see this is not the most exciting part. But it does go pretty quickly. Yep, and we can watch that fun graphic display on the bottom. So now we've replaced the pointer LFO, and you can see that running, and we can actually see that already work. As we increase the LFO depth, the pointer is now going crazy, and as we lower it, it doesn't go as far, and here's our frequency. Right? And we can actually turn the LFO entirely off by just scaling it all the way down. It might be nice to implement an LFO toggle. That's something I'll have to decide if I want to do later. But now what's nice about turning the LFO off is I can now control the pointer location manually, which you can't really do once you turn that LFO on with any amount of depth. Okay, we're making progress. Let's keep going. And actually, maybe for the sake of this feed, I won't go through every single one of these, because that will be pretty time consuming. But you know what I can do is I can show you how we do MSDP buttons. So this rotate toggle, I prefer to use toggle buttons. And we use these in a number of MSDP modules. And we actually use these in some of the templates. So I'll grab a button from the templates. So back over here, let's see. I know we use this for the file effect tutorial. Yeah, so for example, play stop, that's a toggle, but as a nice big button. And I always preferred that. This, I'll just grab it, so copy paste, right? And I'm going to use the shortcut, the keyboard shortcut, Command C, or Control C if you're on PC, which I am actually, and Control V to paste it. Now I just pasted the button, not the parameter, but that's okay. So let's, if we go to the inspector, we'll see there's the text off label and text on label. What parameter is this? 11, 12, 13, 14, 15, 16, 17, 18, 19. This is parameter 19, so we'll call this 19 rotate rotate off, rotate on. Because what that will tell us will be you click on it and it will be rotated, right? And rotate off. So again, I don't think I'm going to replace every single one of these parameters right now, since that would take more time than we really need. And I've already gone over how to do that. But some of the more interesting ones I'll go ahead and take care of. So there's that button now on the back end. I believe I placed all of the fractal exclusive stuff on the end. Yeah, there's the rotate button right there. And we don't really need that or that. We just need the left output of that button, because that will output the same thing as a toggle. On and off, 0 and 1, just like a toggle would. And we always need the MSDP parameter object, msdp.param, and this is parameter 19, and we'll set that to a default value of 0. Plug it in, connect it there, and that's good to go as soon as we add the scripting name p19. All right. So back in presentation, that's way bigger than we need it to be. But we've got the room for it, as you can see. So I think for now, that'll be okay. So, you know, if, when I create this entirely, I will ultimately replace all of these dials with the MSDP dials. But for now, let's move this stuff out of the way and do a quick organization of the final tab, which will be the envelope tab. Now, we won't need all of these objects. I think what we really want here is just what we have between here and here. So we have amplitude envelope and FM envelope. All right, so this is one of the easier tabs to make. Just 8 dials. Again, not going to replace all of them, but I will go ahead and replace a couple of them for anyone who's just joined us and is curious about that process. yeah, I mean, as a basic design, this will get tweaked further, but for now, this will be fine. So now we're thinking about the envelope tab, right? Back to presentation view. Okay, so we have on the basic tab, we have parameters 1 through 9. In the advanced tab, we'll do 10 through 19. In the envelope tab, we have 8 more. So that'll be 20 through 27. 21, let's see, 80 SR, 21, 22, 23, 24, 25, 26, 27, and 28, right? 20 to 28, I know how to count. So I'll just replace a couple of those now. Let's see, here's the amplitude envelope, and here, let's kind of nudge these aside, here's the frequency envelope. Like before, it's a copy and paste mode. We'll take the small MSDP dial, and this is going to be, the first parameter will be 20 for the amplitude attack, so we'll first go into the B patcher. Let's see actually how he's scaling that. So the attack goes from attack of 0 milliseconds up to 1 second, so that's 1,000 milliseconds between that. And that does look exponential. I like that. So we will do 20 attack, maybe ATT for short for right now. Low value of 0, high value of 1,000. And it is floating point, and we'll leave the exponent to 3. There it goes. It's not the prettiest. I need to figure out something to do with the floating point values when the numbers get that large. You can see it kind of going off the edge of the dial there. But that will come with an update, and then once that updates out, all the dials across the system will be updated. So for now, that will be good enough. Then over here in the MSDP param object, we set that to parameter 20, and let's set the default attack time. I like a 20 millisecond attack on my envelopes as a starting point. And then finally update the scripting name to P20. Hook that up, and we can replace the old attack. We can get rid of that effectively. Where did that go? Attack, right there. So you can see that an MSDP dial takes up actually just a little bit less space than one of the Ableton Live dials, but it's fairly equivalent. So you can use those dials when you're planning if you want to know how big they'll be. And that's true for the other sizes as well. The Ableton Live panel dial is about the same size as the MSDP full dial. And then, you know, just for our purposes now, I'll make one last dial for now, and I'll update the rest later. I'll set 28, parameter 28, to be the release of the FM envelope. So, our favorite command, copy and paste. Actually, that was a duplicate command. So if you want to duplicate any chunk of code in Max, you just highlight the code you want to duplicate, and then instead of doing the copy command, which would be Control-C, you do Control-D. That's duplicate. All right. So we're just sort of quickly putting in the last value for the third tab, which will be decay. Now decay goes from 0 to 5 seconds, and again, this is exponential. Okay. So let's see, what if we did it like, I'm just kind of curious. 28 decay, DEC for short, 0 to 5 with an exponential, with an exponent. Ooh, you know, I kind of like that. I think that's a little bit nicer than setting it as milliseconds. Because, I mean, ultimately it is. We're still thinking of these as small values, right? That then scale up to large values. So I think I'll go back and change the attack dial to work the same way, but first I need to make sure I update the MSDP parameter object. So I'll set that to P28, and then update the scripting name. And of course, delete the original. Don't need it anymore. All right, so let's see. Instead of 0 to 1,000 milliseconds, we'll do 0 to 1 seconds for the attack. Yes, I like that so much more. It fits really nicely into the size of that dial. Okay. Oh gosh, I'm a dork. Decay was not parameter 28. Release was. Attack, decay, sustain, and release. Well, is that value too high? Yeah, there we go. Well, for now, I'll just fix that. I'll set that back to 26. 26 with the default of what? A good decay time is maybe 0.2 seconds. That's still kind of long, but it's pretty good. And then make sure I update the dial to say parameter 26. Yeah, silly me. I see where I went wrong. There's sustain and release, and there's index and depth. And those are the two that we're going to actually put in the second tab. Okay, so now I've sort of figured out what's going to go into every tab, and we've got 28 parameters across the basic controls of this system, which is pretty massive, I have to admit. But, you know, it is what it is. More control for the user, right? So we have to think about what other parameters we have in front of us. Just looking at what we see here, I can see tabs, right? Maybe we want to give the user the ability to automate control of the tabs from somewhere else in the system. We also have the controller toggle and the flush command. And if you really wanted to do the keyboard offset, you could do that as a parameter as well, but I typically don't. I think I'll just do 29 for the tabs, 30 for the controller, and 31 for flush. Yeah. So let's just set that up quickly. We already have the parameter routing for the tabs. We just need to replace it P100, which was that placeholder, with P29. And then the scripting name should also be P29. And then our controller toggle. So let's make our parameter for that, and we can actually get rid of the load mask in this point. So here I said that anything in the burnt orange panels should not be tweaked, but this is a tweak that would actually be fine. This wouldn't hurt anything. This is just sort of assuming you don't necessarily want to automate that toggle, but it's better to give the user more control, right? So let's make our parameter object, msdp.param. This is parameter 30, and we'll set the default to 1, because I like to have the controllers start already working. So plug that in, plug the output of the controller into that parameter object, and then set the scripting name, P30. And then finally, our flush. Again, one that not everybody would necessarily make into a parameter, but I like to provide control. So one more new MSDP parameter object, msdp.param, P31, and oh gosh, well, let's start flush with a bang. What that in effect will do is it will make sure that when the synthesizer loads the module, the keyboard will be cleared. So anything that you accidentally saved last time will not be caught up this time. I need to make sure to set the scripting name to P31. And so, you know, theoretically, we have now built all of our parameters. Now, I did leave a lot out just for time's sake, but we do have the entire keyboard first tab set up. We have parts of the second tab and parts of the third tab set up. So what I want to look at next is how to actually make sure that we're only showing one tab at a time. Because we want to see either this, which is tab 1, this, which is tab 2, or this, which is tab 3. I haven't laid that out very intelligently. Maybe I'll just bring this up here. Tab 1, tab 2, and tab 3. Now the trick to doing this is you want to make sure that everything that the user sees has a scripting name. We have to have that scripting name in order to hide and show different objects. I don't actually want those. I think that will be enough. So let's get started. I'll do this pretty quickly. This won't take long. And this is normally the way that I organize this just for expediency is I will say the tab, the first tab will be A, and this is the first item, right? And so this will be A2. A3. Oops. Every scripting name must be unique. You cannot have duplicates. I wonder if I'm going to mess anything up if I... Well, we'll find out. If something stops working, we'll know why. A4. Where? Oh, here we go, scripting name A5. I need to put this back over the original. And I just work through this. A6. Oof. A7. A8. A9. I won't go through all of these in every one. I just want to finish demonstrating this. A10. A11. A12. I know this is super exciting. A13. A14. Almost there. A15. A16. And finally, last but not least, A17. So now we've given a scripting name to everything that's going to be in the first tab. Let's look at how to use that scripting name to show or hide it. Here we have that tab code that was copied over from the tab tutorial. Again, that's source code, system files, modules, templates, module tab tutorial. I just opened that up. Yeah, I'll go through it one more time. I opened that up and grabbed just this little chunk of code right here and copied it in. All I needed to do. So this is the tab object. It's a max object, and it goes into a subpatch called toggler. Now, you'll see here it's we have a select object, which is going to select the number that comes out of here. And what that means is that when I hit 1, when I hit this first object, that's actually the 0th object. So it'll select 0, and we'll get a bang. This is the first object and the second object. And you can see I have these subpatchers, tab 1, tab 2, and tab 3. If I wanted more tabs, I would need to build more subpatchers, and I would need to expand the select object. So if I want 4 tabs, I'd have to set this to select 0, 1, 2, 3, and I'd have to make tab 4. But that's not the case. I have the perfect amount of tabs here. So I'm going to open the tab 1 subpatcher, and what we have here is a list of the scripting names for that tab. And you can see there's some default values there, and I'm just going to replace that with the scripting names I just made, which was A1 through, what was the last one? Let's go back and look again. I think the last one was A17. And so this is just a list of names, no spaces. Or no commas. Spaces, yes, no commas. A9, A10, A11, A12. You can see it's butting in there. A13, oops, A13, A14, and A15, A16. I think I did to A16, but just in case there's A17. I'm going to copy and paste that to here. Now, one of these routes will show the items, and the other route will hide it. And now, if we click, look at that. Those items only appear when we're on the first tab. Otherwise, they won't. So, you know, I'll just go ahead and throw that over here, place it. So you can get an idea of how that will work. I'll just do a couple of B and C to finish off that demonstration. So I'm going to renumber these later. This is just for a little bit of a demo. There's B1, and I'll call this B2. I'll call this C1. And I'll call this C2, but you could see how you just have to run through these one at a time and number them off like that. Then back in our toggler subpatch, which again we got to underneath the tab object, and we'll replace this content with B1, B2, B1, B2. So those are the names that I created for the second tab. And then finally, and there's probably some even more efficient ways to do this code-wise. This is just what I do right now, and I'll probably improve this as my workflow improves with time. So if we go back to our display, we can now see when we're in BASIC, those objects, those interface objects from the second tab, are hidden because I'm in the basic tab, and they'll only show when we're in advanced. They won't show on basic or envelopes. And then the envelope tab has those two, right? So you can see how I could finish that process just by going through and naming all of them. But I've been going for a while now. We're almost at 2 hours, and my voice is getting pretty tired. So at this point, we're actually ready to do some testing. We'll only be able to really test out the first tab, since I didn't finish all the parameter routing for the second tab and the third tab. But I mean, hey, we're ready to go. We're just ready to try out this first tab in its entirety. And I do mean in its entirety. We can really see this working within within Music SDP. So here's how we test. There's that Wavetable synth that we've been working on this whole time. About time I made a copy of it just in case, because I do break things. If you remember at the beginning of this stream, in our documents tree, we found the Music SDP folder. Now this is separate from the source code and separate from the app build. This is something that gets populated by the app for everyone, right? In the Music SDP folder, we see the third-party includes folder and the third-party modules folder. Anything that gets placed in the third-party modules folder will appear in your pedal board, in your drop-down list with everything else. So all we need to do is take that code, modules, there's that wavetable synth that we just made, and I'm going to cut it, because I have a backup over here. Otherwise, I'd probably just copy it. Back to Documents, Music SDP, third-party modules, and paste. All right, so I'm going to put the visual screen back over there. And now let's try this out. Let's open up a new board. And here's our drop-down list, and at the bottom, there's the Wavetable synth that we just finished building. And look at it go. It's having a good time. And I just realized we're not going to be able to control the speed of that because that's on the second tab, and the second tab is not within the viewport. But you can see everything lays out pretty well. I'm going to have to tweak this further because you can see it does get cramped around the bottom. But I mean, gosh, that works pretty well. So let's set some noise. Let's set the scale up real high. And let's play a note now. I don't know how loud this is going to be. This might not even... Okay. So there's that. It's playing. And we can play another note. Thanks, Pedro. I just got that note. I'm going to flush that. And you can actually see, here's back to the keyboard, back to the hardware. It works, right? Timo Hooglin says himself that this is more of a bass synthesizer, so let's go to the bass range. Hear that nice sound. Yeah. Let's scrub around. Change the scale. Lower the smoothing. Okay, so we know this works, but let's actually test out other parts of the MSDP system. One place that I like to go to after loading a synthesizer into a test board is I'll pull up a MIDI arpeggiator, right? Something that can play this synthesizer. So I'll just put in, let's see, a C major chord. We'll offset that really low. And you'll notice one other thing that I didn't point out before was the naming is actually automated for you. So we didn't have to do anything in the code to have the Wavetable synth name appear as our default ID name. That's all taken care of. So whatever you name your patch, that's the name that you will get as a default module. So I'll copy paste that into our arpeggiator. Fingers crossed. Hey, it's playing. Great. I like when I do things right. Kind of weird sound, but it works. And of course we can do this in conjunction, right? So I can play a note on the keyboard. And I can play multiple notes. It's working polyphonically. perfect. Let's turn the arpeggiator off for a moment. All right, now the big test, the big challenge comes when we save the board. If the parameter functions worked properly, everything that we've chosen here as our current settings should save and recall. All right, so let's mess with some things. I'm going to take our XY coordinates. Now this is actually not going to reload properly, that view, because we didn't hook that up. And the pointer won't reload properly because it's being controlled by the LFO. But what will work is the waveform select, so we should come back to the noise, the scale, the smooth, the routing, and the volume. So let's even test the routing. Let's set that to like A5. Just some defaults, we can test it later. Let's turn the controller off too. All right. Ready for this? Okay, let's save the board. I'll call it wave 1. And let's hit load. And let's load wave 1 back in. Fingers crossed, fingers crossed. Yes, we got it. And you can see we got it because the controller's off. We are at the noise Voronoi selection. The scale is where it is, the smoothing is where it was, the volume is where it was, the output's where it was. Everything is right where we left it. So at this point, you know, there's some things that I need to finish on the back end. I need to get those tabs worked out. I need to place them in. But effectively, that's the whole process. So we have, over the course of this last 2-hour session, we have walked through how to download the source code, open it up, find the templates, find the appropriate code in there, and translate something that had been built for us into a functional music SDP module. And of course, I have some final work to do on my end, cleaning things up. But that's it. That's the whole process, start to finish. So for everyone who joined in at one point or another, thank you for joining in and thank you for watching. I am getting pretty tired because I talked through those 2 hours straight, but I do see that there are a couple of people in the chat. So just like our last live stream, I guess I'll take a few moments to answer any questions that you may have. I don't know who's in the chat though. I just see that there are 2 people. I know Pedro's there. I'm not sure who else is there. But yeah, if you have any questions, if there's anything that you missed that you'd like me to walk through, any curiosities, let me know now. And I know there is a lag, so I'll give you all a moment. Bum 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 ba-dum. Pedro, you got anything for me? Thanks for joining. I really appreciate it. I'm gonna go to the YouTube channel directly to see if there's anything that I'm missing on my other screen. Okay, says it's streaming. That's good. Didn't break anything. Just waiting one moment to give you guys time, because I know there's a delay. All right. Well, if there are no questions from the audience, then I'll just say thank you for joining. Thank you for watching. I hope you enjoyed this. Remember that using these templates, using the objects that are included in the templates, all of this is in the most recent source code on GitHub. This is not the stable source code that is available straight from the Music SDP website. So you do want to go to GitHub to get the new stuff. And all of these functionalities won't be shareable with anyone running the application until the next application update, which hopefully should be out by the end of June. Thanks, Pedro. Just saw your last comment. I appreciate you watching. Other than that, oh, I saw one last person join. Yeah, thank you, Pedro. Yeah, I am going to save this video, so this will be viewable to anyone in the future. It is a bit long. I might trim some things out of it and maybe break it down into sections, because this does more or less walk entirely through the process. Um, yeah. All right. I think that is our time today. I appreciate all of y'all. This is wonderful that I got to do this, and wonderful that I got to share this with everyone. I was going to do it anyways, but I really needed to do a new video of this process because it's changed drastically from where it was a year ago. This is significantly streamlined. The whole process goes by so quickly. I can't believe that I almost finished building a module in 2 hours. I mean, that's not a lot of time, right? And so it's great that we now have a new resource to share with the community, because it would be wonderful to get a host of third-party modules developed. Remember that as part of the copyleft agreement that you agree to when you use the source code, you do have the rights to distribute any modules that you make. You can even sell the modules. The only requirement is that with this license, you must also sell your modules or give your modules away as open source. So open source doesn't mean it has to be free. You can still charge money for it. You don't have to give me any royalties. You don't have to announce that I'm connected to it. It can just be your own project and your own way of making revenue. But whether you sell it or whether you give it away for free, making more modules will only make our system bigger and more exciting and more fun for users today and in the future. So with that, I think I'm going to say good night. Thank you everybody who watched with me, and I'll have more information about new live streams in the very near future. Thank you everyone, and have a good night.